This is lesson 5.5, Inequalities involving absolute value. Before we start solving inequalities that involve absolute value, let me just very quickly remind you of the definition of absolute value. The term absolute value measures the distance from zero on the number line. So, we will be looking at solving absolute value inequalities, and there are two kinds that will be treated differently. There's absolute value inequalities that are less than or equal to. These are going to be graphed as an intersection. Remember that we referred to those as the and compound inequalities. So, if you have a less than or equal to absolute value inequality, you will think of it as an intersection or an and type of compound inequality. It will become a compound inequality because you'll recall that when we solve absolute value equations, we would separate two cases. We would have to consider case number one, where that which is inside the absolute value bar is positive, and case number two, when what's inside the absolute value bar is negative. Well, the same is true here. We will be considering two cases. So case number one is the positive case. Case number two will be the negative case. Okay, so let's explore them. M plus 2, the positive, M plus 2, is less than 11. And then the opposite, or the negative of M plus 2, is less than 11. Okay, let's work on solving the positive one first. So let's subtract 2 on both sides. And we see that M is less than 9. M is everything less than 9. In order to solve for M here on the negative side, because this negative is as though we multiplied what's inside the absolute value bars by -1, to undo that, we'll divide by -1 on both sides. Let's recall that when we divide both sides by a negative, what we will do is flip the inequality. So this is M plus 2 is greater than -11. Let's subtract 2 on both sides, and M is greater than 13. Recall that this is an and situation. So, we could write our solution this way. I'm sorry, this is -13. There we go. So we can write our solution this way. All values for M where -13 is less than M, which is less than 9. And here's how we'd graph that. So let's say 0 is about here. We'll have positive 9 there, -13 there. Open circles on both those numbers. And then M is everything in between. That's what will be highlighted. Okay, so again, because this is a less than absolute value inequality, we will treat it as an and. It becomes an and. Okay? All right, let's go on to number 2. Let's look at number 2. The absolute value of y minus 1 is less than -2. Well, we know that the absolute value of a number cannot be negative. And we know that anything that is less than -2 has to be negative. Everything less than negative 2 has to be negative. Therefore, we can resolve this quickly. This is a no solution. Okay, let me just go over this very quickly. The absolute value of y minus 1, that means the distance between 0 and this number, y minus 1, is smaller than negative 2, so it's a negative number, and it's impossible that distance be negative. Therefore, there's no solution. All right, let's go on to the second kind, the other kind of absolute value inequalities. This time we're going to look at the greater than or equal to, and these are graphed as a union or as an OR situation, an OR compound inequality. Again, we're going to explore two scenarios, two cases. The positive case for this absolute value inequality, and we're going to look at the negative case for this absolute value inequality. Okay, so let's do the positive one first. We have 3n plus 6 is greater than or equal to 12. And we can go through and solve this very quickly. 3n is greater than or equal to 6. Divide by 3 on both sides. So we can say that n is greater than or equal to 2. Now on the negative side, remember, we're going to take what's inside the absolute values, 3n plus 6, and say the opposite of that, greater than or equal to 12. Remember that this is a negative 1 on the outside. We're going to divide both sides by negative 1 to get rid of that. But when we divide by a negative, we have to flip the inequality. So let's bring this down. 3n plus 6 is less than or equal to negative 12. Let's subtract 6 on both sides. We have 3n is less than or equal to negative 18. We'll divide by 3 on both sides, and n is less than or equal to negative 6. Once again, this is an OR compound inequality. So we can say that this is our solution. All values for n where n is less than or equal to negative 6 or n is greater than or equal to positive 2. And let's graph it. So I would put 0 here, positive 2 there, negative 6 there. We have closed circles on both of those. And so n is smaller than negative 6, greater than positive 2. And that would be the graph of our solution. Okay. Okay, try number 4 on your own. Remember that you have to explore two cases, the positive and the negative. And because this is a greater than, you'll have to graph it, of course, as a union, an OR compound inequality. Pause the video now. Okay. All right, check your solution. I have all values for k where k is less than negative 4 or k is greater than positive 3. And there's your graph. Okay, let's go on to number 5. We'll do the number 5. Okay, copy it down. The absolute value of negative 2c minus 3 is greater than negative 4. Okay, because this is a greater than negative 4, there are positive numbers that are greater than negative 4. So it's only when you have a less than a negative number that it's a no solution. In this case, we can solve. Okay, so we'll look at the positive and the negative cases. All right, so let's look at the positive one first. So we have What's inside the absolute value bars? Negative 2c minus 3 greater than negative 4. Let's solve this. Let's add 3 to both sides. Negative 2c is greater than negative 1. Let's divide by negative 2, and let's recall that when we divide by a negative with an inequality, we must flip the inequality. So c is everything less than 1/2. C is less than 1/2. Okay, now let's look at the negative scenario. The opposite of negative 2c minus 3 is greater than negative 4. As we divide both sides by negative 1, that cancels out the negative. We have negative 2c minus 3 is less than positive 4. And now let's solve. We'll add 3 on both sides. Negative 2c is less than 7. Divide by negative 2. Let's recall we're dividing by a negative. We have to flip the inequality. C is everything greater than negative 7/2, or we'll call it negative 3.5. Okay, since this is a greater than inequality, we know it's going to be a union. We're going to combine the graphs of these two. Okay, it's an or. All right, so let's look at this graph because I'm looking at these numbers and I can tell what's going to happen. So let's say this is 0. This is positive 1, so this will be 1/2. We have an open circle there. We have negative 1, negative 2. Here, let me give myself a little more room here. Negative 3. 1, 2, 3. Oh, a little further. I just want to be sure that you can see the graph here. Negative 4. So negative 3.5 is here. Now, let's think about this. C is less than 1/2. So if I were to graph that, and I'm going to go ahead and do that using my blue marker, less than 1/2, it would be everything going this way. That is, C is less than 1/2. Now let's do C is greater than 3.5. We would go this way. And if you look, you'll see that every single number on my number line is shaded. Therefore, my solution would look like this. All values for C, where C is all real numbers. All real numbers. Okay? All right. Let's go ahead and give you some independent practice. You'll do number 5, number 8, number 6, and number 7. Okay, make sure that you write down any questions that you have, and we'll go over this tomorrow. We'll be sure to address it. Okay? All right, God bless you. Have a great night.